let's try an exact equation. 1 plus y e to the xy dx 2y plus x times e to the xy y. So let's first check for exactness. Remember, we are thinking of the first part as f differentiated by x, the second part as f differentiated by y. Therefore, if you are to use exactness, the second derivative better commute. And when you take this and differentiate by y, it should be equal to when you take the derivative with respect to x, right? When you differentiate 1, you get, differentiating 1 gives you 0. And if you differentiate y times e to the xy by y, you realize this is a product of two functions of y. Therefore, you need to use the product rule. Okay? So let's use the product rule. Differentiate y by y times e to the xy plus differentiate, well, leave the first one and differentiate the second one by. Come to think of it, I think I usually had the derivative of the second one first, but it doesn't matter. Okay? Product rule just means you differentiate one by one while keeping the other unchanged. Okay? So if you differentiate y by y, what would you get? 1, right? If you differentiate e to the xy by y, well, xy is a function of y nested inside the exponential function, so you have to use the chain rule when you differentiate this. So e to the something differentiates as it is because e dx differentiates as e dx. But then this xy has to be pulled out and you have to differentiate by y. So you have to differentiate this xy by y. This round y means you have to differentiate by y. And what do you get if you differentiate xy by y? X is a constant, so just like when you differentiate 3y by y, you get 3, right? So if you differentiate xy, you get just x. Therefore, the final thing that you get here is the following. Okay. Now let's check the other one. What would you get if you differentiate 2y plus x e to the xy by x? Okay. What do you get if you differentiate 2y by x? 0. So you just have to differentiate the second one by x. And again, it's a product of two things. Like that. And differentiating x by x, that's just 1. Differentiating this using the chain rule, you'll again see that y will come down as the result after using the chain rule. So you do see that these two are indeed the same. And since these two are indeed the same, we know this is exact. Once you've shown that it's exact, then instead of differentiating, you have to undo the derivative. Okay, so you want to take the partial integration now. Remember, we are taking this part as f differentiated by x, so in order to recover our f, you have to do a partial integration. The partial integration of this is, well, first 1 integrates to x, and y is just a just a constant because you're doing partial integration. You're treating y as a constant. So you should really think of this as integration of e to the xy by x. Okay. If you integrate e to the ax, what do you get as the result? So let's try to recall the formula from calculus 2. E to the ax dx is still e to the ax. What do you put? 1 over a. Okay. Now think about why you would need 1 over a. If you did the differentiation using the chain rule, e to the ax will, when you take the ax, the inside function, outside and differentiate, ax differentiates to a. So differentiating e to the ax will create a by the chain rule, and that extra a will be cancelled with this 1 over a, leaving you with exactly e to the ax. So this is the integration of e to the ax. Now, because this is x is same as x, and instead of a, you have y. Remember, this is a partial integration, so y is just another constant, right? So it will act exactly like a here. Therefore, when you integrate, you're going to get x plus y times 1 over y e to the xy, and they will cancel to give you x plus e to the xy. By the way, when you are done with the integration, be sure to include this constant term. In our case, it's a function of y. And for the second one, we have to do partial integration with respect to y. And for a similar reason, 2y integrates to y squared. And for the similar reason, when you integrate e to the xy, it's going to create 1 over x in front. So you get x times 1 over x e to the xy, and x cancels. And that's what you get. Now, comparing the two things, you see that if gx is x and fy is y squared, everything works out perfectly. So you can think of your f of xy, your original function fxy, as x plus y squared plus e to the xy. And therefore, the solution to the original equation is x squared plus, no, not x squared. It's x plus y squared plus e to the xy equal to a constant.